We want to look at now a concept called inequalities. So an inequality is, well, it's a little bit of opposite of an equality, an equation. So it's dealing with algebra. So an example of an inequality might be 3 lots of x plus 2 is less than or equal to 5. So an inequality is one where we use the greater than or less than sign. So we weren't getting one value of x that's going to be equal to a number, but we have a whole range of values that will be equal to x that will satisfy this equation, inequality. So it might look like 7y plus 9 is greater than 10. So we can find different values of y that would make that statement true. We could put lots and lots of values in for y that would make it greater than 10. So when we say lots and lots of, well, we say infinite number of values of y that would make that statement there greater than 10. But how do we find that value of y? So, or x up here. We solve them basically like a normal equation. So let's have a look at this one. 3x plus 2. And we're going to say it's greater than, or it could be equal to 5. So what values of x would make this, the left-hand side here, greater than or equal to 5? So if solving it like a normal equation, there's only one rule that's different we have to think about. So solve it like a normal equation. We get 3x would be greater than 3 because we're going to subtract our 2 off both sides. So we're getting rid of the 2 on that side. We're making sure we subtract on the other side there. And then to go from 3x is greater than or equal to 3, we want x, again, x by itself here, like we do with equations. So we'll divide both sides by 3. And that gives us x is greater than or equal to 1. So that's how we find the values there. So that x is going to be any value that of x is greater than or it's equal to 1 would make that statement true. That side would actually be bigger than or equal to 5. So let's have a look at another one with some division. X on 4 minus 1 is less than 5. So this time it can't be equal to 5, so we're not putting our equal sign in. It's just less than. But again, we follow the same process. We're going to add 1 to our equation on both sides. We're going to get x on the side by itself. So that would be x over 4 is less than 6. And then to get the x by itself, we're going to multiply by 4 on both sides, like we've been doing with our equations. And x is going to be less than 24. So that's how we do that one. Now, one more we want to look at, and this is where the only thing that's different with inequalities and equations and what we do. So if we have a look at this example, 4 minus 2x is greater than 10. So again, to get x is by the x by itself, we're going to subtract 4 on both sides. So minus 2x would be greater than 6. Now this time when we're getting x by itself, we want to get x. We have to divide by the minus 2 to get x by itself there. Now we're dividing negative 6 by negative 2 as well. So that's going to give us a negative 3. But the trick here in this one is that we're going to make it has to become less than. So when we multiply or divide by a negative number, the sign of the inequality actually changes. So you could test it for yourself. Test and see whether this works. Pick any number that's less than 3 and put it in. See if it's greater than 10. And then pick any number that's greater than minus negative 3 and put it in. See if that's greater than 10. It won't be. All the numbers that are less than negative 3 would actually work for this one. So there's the only thing we have to be wary of, is where we multiply or divide by a negative. So when that happens, we change our sign of our inequality. But if it's don't have to do that, it doesn't matter. It doesn't change. That's the only thing that's going to change when we do that. So solve inequalities exactly the same we do with equations, except for that one little trick there. If we multiply or divide by a negative number, then we have to change our sign.